Alright, so this little video is to help you with the revision sheet if you are struggling. So I'm just going to go through every question as much detail as I can to help you with your exam coming up. So first question says simplify the following expressions, show full working. Well, the first thing we need to notice is we've got like terms, so 2p and plus positive 3p are like terms, and we've also got the u terms in the middle. So I'm going to first write my like terms together. So I've got 2p plus 3p plus 3u take 3u. Here 2p and 3p added together makes 5p, plus 3 take 3, that goes to 0, so really you have 5p plus 0, which is just 5p. Next one, we're now multiplying terms. So when we multiply terms, first thing I'm going to do is multiply the coefficients, so negative 6 and negative 5. Then I'm going to multiply d by d. Again, remembering if I don't put a power on with my variables, it assumes they have a power of 1. If I can change the pen, we know that a negative times a negative is a positive, so that's positive 30. And d times d, well, that's going to be times, when we're multiplying powers with the same base, we add those powers together, so that's going to be positive 30d squared. Do I really need the positive 30 at the positive at the front? No, I don't. I could just leave this as 30d squared. Either answer is acceptable. Next one, expand the brackets and simplify following algebraic expressions, show full working. So your full working here could be just you going, I'm going to multiply 3 by c and multiply 3 by negative 4. So 3 times c, that's a positive 3, and I'm multiplying it by negative 4. 3 times 3 is 3c. Positive times a negative is negative. 3 times 4 is 12. So our answer there is 3c take 12. Here we've got 9b times b plus 9b times positive 3. Again, this time we've got a variable with nothing at the front, and we know that the coefficient will be 1. We also know that if we have a variable and their powers are going to be 1. So I'm going to have 9 times b to the power 1 plus 1 plus 9 times 3 is 27 times b is b. Just to simplify this further, we know that 1 plus 1 is 2, so really this is 9b squared plus 27b. Can we add these two terms together? And the answer is no, because b squared and b are not like terms. Next, question 3, if I can get out of the box, says factorize the following algebraic expressions showing full working. So before we were expanding the brackets to get rid of the brackets and come up with an expression, this time we're factorizing, so we're going to put them back into brackets. Like I said to my class, what we do is, first thing we need to know is what are the we need to find the highest common factors of 5t and 25. Well, the numbers that multiply to give us 5 are 1 and 5, and to get t we'll have to multiply by a t. 25 is just 5 times 5. We can see that the highest common factor here is 5 in both, So our highest common factor that we're going to take out, oh, that was not the pen I needed. The highest common factor that I'm going to take out is 5. I don't take out the variable t because there's no t that's common to both. So that means for 5t take 25, if I take my highest common factor out, what do I multiply 5 by to get 5t? Well, I know here I multiply 5 by 1t to get 5t, and I know I multiply 5 by 5 to get 25. Whoops. And it's gotta be, well, we want a 25 that's negative, so that it's gotta be a negative 25. So really, what I should have is a positive, one negative, because my answer here has gotta be negative. And then there's your final solution for that one. 5 outside of 1t plus 5. If you wrote 5 outside of t plus 5, same thing, you'll get the marks. Again, we're going to find the highest common factor. We know that the letters, we know the letters U and C are not the same, so I know that I don't need to worry about the letters as my highest common factor. I know 2 is a prime number, so the only numbers I multiply to give 2 are 1 and 2. Other than 1 and 6, I've got 2 and 3 for 6. Again, we'll have a U here and we'll have a C term there. But since they're not common, I know I don't have to take a variable out. I know that the 2 here and here are common, so my highest common factor is 2, which means in 2u plus 6c, I'm going to take 2 outside of the brackets. What do I multiply 2 by to get 2u? Well, that's going to be 1u, and I know to get a positive, all my variables have to be positive, if that's a positive, and 2 by 3 gives me 6, and I need a c variable in there. Again, you can write this as 2u plus 3c. Now here we don't need to do algebraic solving, it's more just can you remember what expanded and index form is, because all of that relates into algebra union. So if I expand this, then we know to get 2 to the power 3 times 5 to the power 2, well, in expanded form I need 2 times 2 times 2 and 5 times 5 times 5. So 3 2's and 2 5's multiplied together. If we go back the other way, I want to go from expanded form to index notation. I'm going to count how much of each letter there is. So 1, 2, 3. So that's a to the power 3 times 1, 2, 3, 4, b to the power 4. Again, we're going to expand and evaluate. Notice that it says evaluate, so I will need an answer on your calculator. So first we got to expand. So 7 to the power 4 means we're going to multiply 7 by itself 4 times. And then we're going to work that out on the calculator and write down our answer. Alright, so when you put that into your calculator, you get 2,401. For the next one, we've got minus 4 all cubed. So here the number that we're multiplying is negative 4 by itself. So it's negative 4 times negative 4 times negative 4. Just gonna write that a bit better. Alright. And then multiplying across, a negative times a negative is a positive, positive times a negative is a negative. 4 times 4 times 4 is 64. So your answer is negative 64. I am going to double check that. Yep, it is 64. So next we're going to move on to question 6. Simplify the following using index laws. Alright. We know when we multiply indices with the same base, we add the powers together. So this is going to be n to the power 4 plus 5. That's n to the power 9. We know from last term anything to the power 0 is 1, and we know that between 3 and 0 that's a multiply, so this is 3 to the power, not 0, 3 to the power x to the power 0. So this is 3 times 1, which is 3. When we divide indices with the same base, we take the powers away. So this is going to be 11 to the power 8, take 5, which is 11 to the power 3. And the last one, when we're multiplying indices, we know that we got to take the outside base and multiply it by the inside powers. So this is s to the power 4 times 3, which is s to the power 12. So this is no different to what we did last term, but instead of a number base, I've now just got variable bases. It's still the same process as last term. Yeah, it's sorry to just pop in like this, but got a few words that I need to share with you from our sponsor. And you know our sponsor is Cream and Soda drinks from Bundaberg. On them, get on them. It is helping a great maths YouTube channel get off the ground. Alright, back to the maths. Alright, it's great to hear from our sponsors. Again, if you haven't, Bundaberg Cream and Soda, it's a great drink. You should really get on that. Anyway, for this question we have to find the length, and the length of a rectangle is 5 and the width is c plus 3, and we got to find the perimeter and the area. So first thing I'm going to do is go ahead and put in my line markings, and I know that if this side's 5, the opposite sides are 5, and if this side is c plus 3, then this must be c plus 3 as well. So from there, I know that for the perimeter of a rectangle is side plus sum of sides, so I'm going to add my sides together. I've got 2 sides that are 5 and 2 sides that are c plus 3. So then I'm going to collect my like terms. So here I've got my constants, so 5 plus 5 is constant, and plus 3 and plus 3 are constants, and I've also got this positive c and this positive c here. So what I'm going to do is I'm going to group like terms. So if I go ahead and do that, I'm going to have c plus 5 plus 5 plus 3 plus 3. And I know when I'm adding like terms, c plus 3, c is 2c, and then 5 plus 5 is 10, 10 plus 6 is 16, that's 2c plus 16. This is the expression for the perimeter. For the area of the rectangle, we've got to multiply length by the width. So again, I know the length is 5, and I'm going to multiply it by c plus 3. I'm going to put it in brackets because c plus 3 is the width, not just c. So here you can see that now we've got expanding brackets. In other words, we're using the distributive law, and I've got to multiply 5 by c and multiply 5 by 3. So the area is going to be equal to 5 times c plus 5, because 5 here is positive, times positive 3. That means I've got 5c plus 15 for the area. Now the difference here is one's perimeter and one's area. So really, at the end of my perimeter expression, I should have units, and then area, I should have units squared, just to show the difference between perimeter and area. Alright, this question really tripped over some of the year 8s last year, purely because you didn't read the question and they didn't understand what you had to do. So the question says, a year 8 math class was asked to simplify the following expression, show the full code working. Before I even go to B, let's just expand this. And to start off with, I'm going to put bomb dash down the side for a second. And I know with bomb dash that in my question I've got 2 sets of brackets. So I'm going to have to get rid of the brackets first. And get rid of the brackets means I'm going to multiply. Wow, that was shocking. Nope, that's the wrong pen. Let's try that again. This is power of 3, power of 5. I'm going to multiply the outside power by the inside power. I'm going to multiply the outside power by the inside power. So what we have is t cubed times 5 divided by t to the 4th times 3. And then if we solve that, we've got t to the 15 divided by t to the 12th. Now that I'm dividing powers that are like terms, now that I'm dividing powers with the same base, I'm going to take away the powers. So that's going to be 15 take away 12, so I'm going to have t3. Now let's compare that with what Jill has done. So part B says Jill's answer is shown below. Where did he make a mistake? So we can see here that I should get 15 and 12 because I'm multiplying the outside power by the inside power. With Jill's working out, I don't have 15 and 12, I've got 8 and 7, because what Jill's done is they've gone and added those 2 powers together. So that's what we need to say. So B, we'll just say Jill's mistake is that they have added the powers instead of multiplying. And it turns out that this is, it's a B standard question, because one, you gotta multiply the powers, then you gotta divide the powers to get the answer. Like you're using power of a power rule and then the division of power rule. And then you gotta work out what the mistake is. So there's really a few skills we need. So that's an easy B standard if you just read it and apply your knowledge of powers. Alright, question 9. This is when things start to get a bit more complex. So let's have a look at these. So we're going to expand the algebraic expressions and simplify. Again, we've got the distributive law. If I zoom in on that, let's do one at a time. I'm going to take 5p and I'm going to multiply it by all three terms. So the first one, I've got 5p and I'm multiplying it by a constant 6. I've got a positive 5p and I'm multiplying it by negative 3x. I've got a positive 5p and I'm multiplying it by a positive 3p. And I know here 5 times 6 is 30, and so this is 30p. I know a positive times a negative will give me a negative, and then it's 5 times 3 times p times x if I was to write it out. And again, I've got a positive times a positive, so that will be a positive. Multiply my coefficients together, 5 times 3 times p times p. Again, 30p, we've already solved that. Negative 15, and then alphabetical order is px. Again, positive 15, and we know here p's got a power of 1, so we're going to add the powers together, which gives us on the end p squared. So this is going to be positive 15p squared as our final answer. So we've just applied the distribution law 3 times instead of twice, well, into 3 terms instead of into 2 terms, which we normally do. And then if we look at B, it's what we usually do. We've got the distribution law that we've applied it twice. Oh my god, that is not what I want. Let's go back. I'm going to multiply this 3x, negative 3x by those 2 terms, but the part where it becomes a B standard or more complex is I've got to do the distributive law twice. I'm applying it twice in the question. So again, we've got negative 3x multiplied by x plus, sorry, not plus, that's a negative 3x, negative 3x times 5 plus 2 times 2x squared. Let's just write that a bit better. You know what? I'll put the second part in my galaxy pen. So 2 times 2, oh, that's worse. Let's pick a different, let's just go blue. So positive 2 times 2x squared, positive 2 times negative 3. So that's really what we're doing. We're doing the blue side and the black side. Even though it's the same question, it's the 2 bits that we have separated together. Oi. Well, that took a turn. Alright, apologies, we're back. Alright, let's simplify this. I'm going to first of all put here negative 3. I know x has a power of 1, x has a power of 1, so this is going to be x1 plus 1. Here I've got negative 3 times 5 times x. I'm just writing it out. And then our blue side, we've got positive 2 times 2 times x squared plus 2 times negative 3 times x. Just gonna write it out. This means I've got negative 3x squared. Take 15x. And then in blue I've got, well, positive 2 times 2 is positive 4 times x squared is positive 4x squared. A positive times a negative is a negative. 2 times 3 is 6. And we're going to multiply it by an x. So then there's our terms. And then what I didn't mention in part A is we don't need to color like terms here because p, px and p squared are not like terms. Whereas here we've got like terms. So I know that's an x squared term. I've got another x squared term, so there's 2 like terms there. And then I've got 15x and negative 6x. They're like terms, so let's group those together. So I'll have negative 3x squared plus 4x squared, and then negative 15x take 6x. Negative 3 plus 4 is 1x squared. Negative 15 take away 6, that's going further back into our negatives. So that's 21x. So there's our final answer for part B. So part A, apply the distributive law to 3 terms. Part B, apply the distributive law twice by expanding 2 brackets instead of 1, and then collect like terms and simplify. Alright, so let's look at question 10. We got to simplify the following expressions. Now, these are not A standard questions, but they're pretty close. So if you can do them, this will help you work out most of your A standard questions. But we'll do that after a quick intermission. And this is why we're having a quick intermission, because someone's decided to wake up. So we're going to have to take a quick pause from the math, even though you really want to do some algebra. Do you want to do some algebra? Algebra's great. But you can't touch the laptop. That will kill the algebra. And we don't want to do that, we want to do the algebra. Hey, do you see your face? Look. Yeah, it's right there. You're pointing. Yeah, wave at all the kids, say hello, hello. Yep, they'll see you watching this, so just say hi. Yep, cool. Good day, bye bye. Alright, sorry for that brief intermission. Special guest arrival was not planned, so had to take care of that. So let's get back to this. We're going to simplify the following expressions. Again, not an A standard, but if you can do these, you can pretty well much do your A standard. So let's have a look at this. First thing I do notice is that I'm dividing an algebraic expression. So I'm going to divide my 2 constants together, negative 12 and negative 6, multiplied by my 2 like variables, so P6 and P5, multiplied by Z7 over Z4. We're dividing the variables, but we're putting a multiply between each term. So let's go ahead and simplify that. Negative divided negative is a positive. 12 divided by 2 is 2 times, well, when we're dividing, we're going to take our powers away. So that's going to be P to the 6 take 5 times, again, Z to the 7 take 4. And if we simplify that, we have 2P to the 1, sorry, or just 2P by itself, multiplied by Z cubed. So 2, oh, I didn't move that. So 2P 1 to the power 3, or just 2P Z cubed. That's a bit big. And there's our answer for that. With factorizing nice expression, the camera across, first thing we're going to do is find the highest common factor for 16f squared b cubed 3. Well, we know 16 is 1 and 16. I know 2 and 8 multiplied to give 16, and 4 and 4. And my variables, I've got b. Sorry, let's go from the start. I've got f squared, so that's f times f. I've got b, and then I've got q cubed, which is q times q times q. Next I've got negative 12f b cubed q3. And I'm going to shrink that a bit. Move that down. Whereas all my terms for 16 and 4 can be positive, since I've got this negative at the front, I'm going to need one positive and one negative for each of my factors, or the numbers that multiply to give 12, because we know a positive times a negative is going to be equal to 12. So what that means is I can have negative 1 and 12, I can have positive 1 and negative 12, I can have negative 2 and 6, and 2 and negative 6, I can have negative 3 and 4, I can have negative 4 and 3. And then to get fb cubed cubed, I need 1f. b cubed is b times b times b, and then q cubed is q times q times q. And then going down, I have 4. I have 4f squared b squared updated q cubed. Again, I know the factors of 4, and this time 4 again is positive, so I only need the positive terms, 1 and 4, 2 and 2. And then I know for f squared, I've got f times f, b times b, q times q times q. Now I'm going to look at all my terms here, and I'm going to highlight the common terms to find my highest common factor. So let's have a look. I can see straight away that I've got an 8. That's my highest number here, but no 8 and 12, so it can't be 8. I can see 4 is the common term, so I've got a 4, positive 4 here, positive 4 there, and I've got a positive 4 there. So immediately, for my highest common factor, I can say I've got 4, but now I've got to look at the variables. So looking at our variables, we have, well, at least one f must be common because there's only one f here, so I can only take one of the f's. I've got a b here, 3 b's there, and 2 b's here, so at least one b must be common. And I've got q cubed, 3 cubes, 3 cubes, and 3 cubes again, so all q terms are common. So if we go back to our highest common factor, that means we've got 4, 1f, whoa, let's try that again. We've got 4, 1f term, 1b term, cube, 3 q terms, so q to the 4th. And then again, we like alphabetical order, so I'll switch f and b around so it's alphabetically correct. So our common term is 4, bfq cubed. So what we're going to do for our answer here, we're going to first write that expression down. So 16 f squared b cubed it's a bit squished, but that's what it is when we write it down. Alright, I needed more room, so I've written it across the last question. Alright, so here we found out that our highest common factor is 4bfq3. So that means I'm going to take 4bfq3 out, and then we're going to work out what we need to multiply. So 4 times what is 16? That's 4. I've already got a b, so I don't need to have b in here. I've got an f, and I need f squared, so I'm going to multiply it by f. I've got q cubed, and I've got q cubed here, so I don't need anything else. 4 times what is negative 12? Well, that's negative 3. I've got 1f. I've got a b here and a b cubed. So b times what is b cubed? Well, that's b squared, or b times b. And then I've got q cubed and q cubed, so I don't need anything there. Plus 4 times what is 4? That's 1. I've got 1f. Here I need 2f, so I've got to multiply by an f. Here I've got 1b. Need b squared, so I've got to multiply by a b. But then, sorry, I like alphabetical order, so I'm going to put them in alphabetical order as bf, and I've got q cubed, and I've got q cubed, so there's our factorized form. And if you can do that, you can pretty much do your A standard. So good job. And that's it, that's the end of the video for today. Hope you guys watch it, and hopefully you pass or do real well.